For the past few months, I had to take these types of videos over and over again, probably dozens of times of these different build events where I have to, as objectively as possible, take a video of them working. It's really boring, and I had to do these for so many different events, it got really tiring. So I wanted to have a device that could take these videos for me and possibly even just rotate around automatically to make sure everyone is in frame. The other motivation I had for building this project was there was a really cool feature on the new iPads where they'd basically have a camera that would allow you to be followed using a 120-degree angle camera and an AI system. I wanted to copy this, but using a way higher depth camera and having a mechanical moving system, so there'd be no stutter and it'd be as high quality as possible. Okay, the next thing we're going to look at is the hardware and the software of this project. So the hardware I'm using is basically a Raspberry Pi 2, which you can see in the back here. It's mostly hidden by this case I made, but you kind of could look inside. There's also this monitor that I have. It was really cheap. I had this for a few years. I basically made out of I ripped out an old laptop screen. The computer didn't work, so I could just take out the screen, and then I could get a specific driver from eBay for $30. So it's really cool if you ever want to build a cheap monitor. It took $30 and pretty much no engineering experience. Uh, After that is this camera that I bought for this project. It's called the Canon EOS 80D, and it's pretty good megapixel count, better than my phone, and it has really good low light performance. And this is a tripod I got for free, from a yard sale. And then I have these 3D printed parts here, such as holding up the camera, and this monitor case I made. It looks a bit ugly since I have all this duct tape here, but that was just to make sure everything is kept intact. Okay, onto the software. So I'm using a Raspberry Pi, which uses Linux, which is an open source software, which is really cool because I can do so many things that I can't do on Mac OS or Windows, but it's also caused me so many problems. But let's first look into the code. So this is basically my main file. I call it the project droid. And basically, there's a bunch of different libraries I have to import, such as OpenCV. There's this library right here. Oops. Where I import this sort of Excel sheet of different face examples. So a computer can identify what is a face based on all these examples. Sort of like how you learn the alphabet. You look at it a bunch of times and you learn it. And then I basically create this window where I can put an image. Next, I have this function that stops background tasks on the camera. And I have this just while true loop, which will continue until I press the escape key on my keyboard. Basically, it tells the camera to take a picture, save it on the computer, then it will find that picture, and it will run the facial recognition software on it. It will tell you where the face is, how many faces are there, and currently it doesn't show that on the screen, or put a border around the face like it used to, but I'll be adding that again as soon as I fix a bug. And then it will display that image. And I had to modify the code quite a bit because the built-in libraries were just really slow, and I had to work around that. So I used this other library called Pygame. Okay, so I think we'll just do a demo right now. Okay, I'm going to now show a demo of the code. So I have this really cool remote here, which acts as a keyboard and a mouse. So I can basically control the Raspberry Pi with just this and no mouse or keyboard otherwise. So I'm going to have some of these other keys programmed to do specific things, such as quit the program or turn it left and right, but right now all it does is I can start the program and run it and end it. So I'm going to start it right here, and on the right side is the terminal window, which is kind of like the where some outputs will show up, such as information. But here in this main window, you'll see currently a black screen, but in just a second you'll see, oh, there's me. And the frame rate's really low. It's like 2 frames a second. So like if I wave here, it's like that. I can make it a bit faster, but that's like pretty much the fastest I can get it without it being super buffery, and like quitting other parts. Okay, so you just saw the software, and it works pretty well. I could leave it like that, and it would be, I guess, decent. But there's a lot of things I'm going to be adding into it later on. So the first thing I want to add is have it show visually on the display where the faces are. It's a pretty cool feature. It looks really cool, like high tech. So that's just one easy feature I can add. I just had a bug, so I didn't fix it in time for this video. Second thing, I want to have like a countdown timer, and it says audibly 1, 2, 3. So that would be pretty cool. Very simple to do. I just add a speaker or two here, and that's about it. And the third thing, this is a big thing. I'm going to be basically adding a motor to the back right here. You can see I have some of the gears already created, and I have all the parts necessary. I'm just working on attaching them. So eventually, the software will determine where the face is inside of the frame of the camera. It will then decide if the person or subjects are not in the center of the frame or within 2/3 of the border. It will move left or right, like this way, and pan like really smoothly. I can also control it with my remote. So that's another feature that is really important for me to add. That was kind of the main feature that was super important for me to do. I just had so many difficulties with this project as it was. I didn't have time to finish it. This entire project has basically just been problems and working to get solutions. Uh, Basically, the first problem I had was installing OpenCV. It took like over a week for me to figure out how to install it the first time I did it. Luckily, I wrote down how I did it because later on I messed up stuff and I had to go back to find how I did this. Okay. The third thing had a ton of problems with was installing these different libraries. There's like a dozen different libraries for my program to work, and I just didn't know what programs I needed. Uh, I kind of just had to write these down eventually after figuring out that this is the only way I'm going to be able to fix stuff if anything goes wrong. And the biggest mistake I made was removing the SD card slash losing power while a program was being operated. The Raspberry Pi does not really have any security measures in place to protect your data or like all your code. So if like the SD card gets removed while the system is running, or if the power goes out, then the system can get corrupted and your files can get lost. And this happened to me twice. I wrote about this in my blog. For more details, you can look there. But I was so annoyed. I spent hours repairing all the damage I caused. Luckily, in my blog, I wrote down how to like go back onto my steps and trace back what I needed to do, so it wasn't like starting over. So all these problems, how I solved these were basically problem solving. I looked things up. I talked to my friends and family, my friends and my teachers, and they gave me some advice. And I just had to persevere through these issues. And that's the biggest thing I learned from this project. There are so many issues you're going to face with engineering, and with a project with such wide scope. And so I've really gotten a lot better in the past few years doing all these different projects, and I hope to continue doing that. If you want more details on my project, I'll be posting it on my website at provocatortech.com, and there will also be future blog posts there and an updated video eventually. Thank you for watching this, and please contact me if you have any questions.